Hey everyone, welcome to the first main module of the Azure Masterclass, Cloud and Microsoft Azure 101. The goal for this module is really to walk through what are the types of cloud service, what is a cloud service. A quick primer on Microsoft Azure. Again, those types of as a service, infrastructure as a service, platform as a service, software as a service, what do they mean? And then getting access to Azure and the types of subscriptions. So this really is a kind of fundamentals level. If you already know everything about the cloud, you could probably skip this one and move on to others. I'm really trying to set a framework in this module. As always, please make sure you subscribe, comment, and share. It really will help you see when I release the new videos and helps bring more people to the video. So cloud services. There are actually many types of cloud service. These cloud services don't have to be in kind of that public cloud over the internet. I could actually think about a cloud service could be within an organization's own infrastructure. You have data centers. I can host a private cloud. Now, a private cloud is really all about having a way for users to interact with the services I'm offering. Maybe a portal, self-service. I'm pooling resources together. So it's not just virtualization, it's adding a certain type of management capability on top of that virtualization to give me a private cloud. So sets of capabilities on premises. It could be from an external party that typically I access over the internet. It's multi-tenant. It's not a rack of servers just for me. That's generally more kind of a hosting scenario. This is actually a set of services that are multi-tenant that are ordinarily over the internet, but there may also be kind of dedicated access over private connections. So think about things like Azure, Amazon Web Services. These are examples of kind of the public cloud. And when I have this, I only access certain levels of the system, depending on what type of service I'm purchasing. Now, some organizations actually share a set of infrastructure, like a community cloud. Some governments, for example, some agencies, will they share a set of common infrastructure, so it's a community cloud just for them. And then, of course, I might have hybrid cloud. I have things on premises, I have things in the public cloud, and they kind of work together. So what exactly is a cloud? Now, there are many definitions. You could ask 5 people in a room and you'll get 7 different definitions. But there's kind of a widely accepted. So the US NIST, they have these 5 critical characteristics to really be considered a cloud offering. On-demand self-service. So as a user, if I've been given permission, and maybe within certain quotas, I can just unilaterally go and consume those resources. I can go and create a virtual machine through some portal. I don't have to put in a ticket and ask someone else to go and create it for me. There's broad network access. For example, I can access these over the network through standard mechanisms. I'm pooling resources together. Often on premises, we end up with islands of resource. This project buys a set of hosts, they buy maybe a SAN, and it's all theirs. And they use a certain percentage of it. Then another project goes and buys their own set of servers and their own SAN. So you get these islands of resource that are unconnected. And all of those islands typically are fairly heavily underutilized and wasting a lot of space. So when I think about the cloud, I'm going to pull them together. I'm going to have resources that use all those different parts of resource, all those different capacities, be it storage or network or compute, and I'm going to bring it together. Rapid elasticity. Now this comes from the fact that we're pooling our resources. We have a larger amount of resource available to us. And when I have that, well, now I can burst. So elasticity means rather than just having this fixed amount of resource, I can scale out. and I can scale back in again. I can change my capacity on demand based on the resource requirement needs. And that's really critical when I think about being able to respond to maybe different customer behaviors. Maybe it's a big shopping day, maybe a new phone is coming out. I don't want always the biggest amount of resource I ever need in a year available. I want to try and optimize my spend, but be able to grow rapidly if I need to. Then it's a measured service. I should be able to see what am I using. I might have quotas. I might have show back. So I show someone what they're actually costing. I might have chargeback. I'm actually going to bill them based on the resources they use. And this is kind of a link to the actual article. Now you're going to see a little theme throughout this presentation. Pizza is one of my favorite foods. So wherever I can, I'm going to talk about pizza. So when we think about types of as a service, I'm going to firstly start off with pizza. And I can think about if I make pizza at home, I'm responsible for all of the layers required to make a pizza. I have to provide the pizza dough, the tomato sauce, the cheese, any toppings, pepperoni maybe. I need the fire, the oven, electricity, gas, drinks, and a table, utensils. I have to provide all of that, like doing stuff on premises. They're a take and bake. I go somewhere, I pick up the pizza, then I have to take it home and cook it. So someone else has been responsible for the pizza itself, the ingredients. I'm responsible for providing the infrastructure and managing the part to actually cook it. So I have to put it in the oven, set the temperature the right way. I have to use my own table. I get pizza delivery. So now all I really have to do is provide drinks and the table. They're cooking it for me. They're bringing it to me cooked. So what's changing is what I as the customer am responsible for. As I move up the layers, I'm responsible for less and less until we get to dining out. Dining out, I'm not really responsible for anything other than shoving it in my mouth. They provide everything. They're providing the end service. I can directly consume that service to meet my need. My need is to eat pizza. When I dine out, I'm not responsible for any component of that. They give me essentially a business service that I can just directly consume. It does the complete picture of what I want. So let's forget about pizza for a second. It's kind of sad. If we actually think about layers of infrastructure, we have networking, storage, and the servers. That's kind of the fabric. We need those things in our data centers to do anything. I have to have storage, I have to have a network, I have to have compute. Then we run a hypervisor. We have virtualization. We very rarely run physical OSs on physical boxes anymore. We carve up a physical machine, we create virtual machines. And then on those virtual machines, well, I install an operating system. Windows Server, Linux, Ubuntu, CentOS, Red Hat Enterprise Linux, whatever that is an OS. On that OS, I then maybe have certain middlewares, I have certain runtimes, Java, .NET, whatever that may be. Then I have my data and I have my application. But on premises, I'm responsible for all of those things. And all of those things have certain amounts of work. Hey, I'm updating firmware on networking devices. I'm worrying about capacity on the storage, upgrading SANs. My servers need physical patching, protection, firmware updates on the boxes. Hey, the virtualization, well, that has to be patched. That requires work. OS, well, anti-malware, firewalls, configuration, updates, backup, DR, lots of stuff to do. So we move to infrastructure as a service. That's really kind of the first public cloud service we often think of. So here the vendor, i.e. Azure in this case, they're worrying about all the core fabric, the storage, the network, the compute. They're worried about the hypervisor. I don't see that stuff. No, it is basically based on Hyper-V. It's not running VMware for the most part. There is a VMware offering, but the default Azure is running on a flavor of Hyper-V. What I get is a virtual machine. I pick the operating system. I can RDP if it's Windows, I can SSH if it's Linux, I can go straight into the OS. I can install anything I want. I'm responsible for everything. I'm patching the operating system. I'm worrying about anti-malware. I'm worrying about backup. There are things to help. So in Azure, there are extensions for anti-malware. There's extensions to push declarative configuration using things like PowerShell, DSE, Chef, Puppet. There are agents to hook into Azure Backup to back this thing up. I can do things about firewalls. So there are things to help me, but the responsibility is mine. I'm updating versions of .NET. I'm updating Java. I'm installing my app. I'm worrying about my data. It's essentially a virtual machine in the cloud. That's infrastructure as a service. That's often where we start. It's the most familiar with us. I can take a virtual machine from Hyper-V, from VMware, even from other clouds, and I can migrate it fairly painlessly to a VM in Azure because they're really the same kind of construct. Now, I'm not worrying. I can't see the hypervisor. I can't see what the real storage is. I can't see what the network switches are. I can't see what the physical server is. I don't care. There are constructs that I can create virtual networks. There are constructs that I can create storage accounts and manage disks to use in my virtual machines. So there are things there to let me connect together to give me the durable storage. But I'm not directly managing those fabric elements. So essentially, infrastructure as code gives me tons of flexibility. I'm getting a VM in the cloud, but there's still lots and lots of stuff I'm responsible for. All that patching, backup, anti-malware, etc., etc. Then we get to platform as a service. Now, platform as a service, I'm really only caring about my app and my data. I focus on writing my application and I can deploy it into a PaaS service. And this is actually how Azure started. Azure started as PaaS because the idea was people don't really want virtual machines. People don't want to focus on the OS and worrying about the OS and all that stuff. They just want to focus on the business value, which is the app. But many things are still VMs. People weren't really ready for the big shift to a pure PaaS. So then Microsoft went back and added in IaaS. But this should still be our goal. If I'm writing something new and I want to deploy it to the cloud, it's saying custom, I should be focused on PaaS. As a company, I very unlikely want to be dealing with, hey, I want to worry about patching operating systems and backing up operating systems and upgrading them and updating runtimes. I just want to write my app and have it run somewhere. And that's what PaaS gives me. So my dog came in and started chewing up the cables. So we have PaaS. And then it's software as a service. I go and eat at the restaurant. It's providing the business value directly. I'm not having to really write anything. There might be some configuration options I tweak. Think of Office 365 would be an example of this. I'm not installing Exchange, the app that provides the business value. I'm not installing SharePoint. It's provided for me in a managed way. It gives me things like evergreen capabilities. It's constantly being updated, saying I couldn't do if it was on premises. And we really try and think about if I'm using a new type of service, I have a new capability that I need, I try and start here. If it's available as SaaS, I should use SaaS. It's less for me to do. I'm responsible for a lot less. And ultimately, the company cares about business value. Just writing apps and managing operating systems doesn't provide business value. How quickly can we provide business value? And SaaS gives me that. Now, maybe the requirement I have is I'm writing something custom. It's not available as SaaS. Okay, so we focused on PaaS. We write our app, we focus on our business logic, it hosts it for us. Now, there are different levels of PaaS. I can think about serverless, like Azure Functions and Logic Apps. They're kind of, there's not even underlying compute that I'm paying for directly. I just pay for the compute I'm consuming. Then there are things like app service plans. There are things like containers, and containers are an interesting one. Some people say they're IaaS, some people will say they're PaaS. With a container, and we'll talk about this later in the course, I pick the image that is the OS. I pick the image that are the middlewares. So you can kind of argue, well, I am kind of picking those things. But then things like Azure Kubernetes Service is a completely managed orchestrator. I have no access to the OS for those things. So I think things like containers kind of float in the middle. It's a kind of gray area on that one. But we have all these different levels, and sometimes I can't use PaaS. Sometimes I have an existing app. I can't rewrite it to work on a PaaS platform. Often it can be fairly minimal. Like there are options of PaaS that can support all manner of languages and runtimes, but I can't. I have this existing app. The person that wrote it has given up life as a computer programmer, is now a monk somewhere, and I don't know what it does. I just have to move it as is and use the infrastructure as code. Or it's some app I'm purchasing, they don't support a PaaS, I run it as infrastructure as code. We have choice. I can run it as IaaS, PaaS, SaaS. Some things I'll have to keep on premises. And one of the key things about Microsoft is they're focusing on that choice. Hey, they have Hyper-V. They have a whole management stack. They have things like Azure Arc. Azure Arc is all about bringing a lot of the capabilities of Azure to things on-prem, to things in the cloud, other clouds. It will go and manage servers. It will go and manage Kubernetes clusters. It will deploy some of their evergreen kind of services like SQL and Postgres for you. So there's going to have different sets of requirements. There are different services to meet those needs. If you've never used the cloud before, it's interesting. I have some customers ask this when they're starting out. In a real public cloud, you're never putting in an order for servers to be racked up. There's no lead time of, hey, I'm putting in this request to this public cloud. In 4 weeks, it'll be ready. That's not a real public cloud. You should think about this massive set of capacity in these public clouds, some of Azure. When I go to a portal or I run my declarative template, there's a ton of capacity just available. The only way is the provisioning of your resource in that capacity. Talking minutes most of the time. There's no concept of have to go and buy the servers and rack the things. If you're using something and it's like, okay, well, from this number, tell them how many servers you want, it'll be ready in a couple of weeks. That's not a real public cloud. So when I think about using things like Azure, I can go to the portal and I can just go and request resources and they'll be there in minutes. That's kind of the key point. Now, when do I use the public cloud? And there's not a right or wrong. You might have a huge investment in your on-prem data center today. Great. But there might be certain requirements you have that I can't meet. I might be moving to a new model. There's new types of service I want to use, things like machine learning. I just don't have those things on-prem. So there is no definitive right or wrong answer. Different organizations have different priorities. Some organizations are just all into the cloud. They want to get to the cloud as quick as possible and get rid of their data centers. Some can operate their data centers at different price points. Now, by and large, if I just look at dollars and nothing else, which is not the right way to do it, but if I did just look at dollars, it's very unlikely you can be as cheap as any of the major cloud providers. There's economies of scale. There's something called PUE, power utilization efficiency. It's the amount of power that goes in and the amount of that power that gets used to actually power the servers compared to other things like cooling. The Azure data centers run at a ridiculously low PUE. So their electricity bill, they buy a lot of it, they can run far, far more efficiently. For some companies I've worked with, just the electricity alone costs more on premises than it would cost to run the resource in Azure. So it's kind of crazy. Now, different companies can run at different costs, but pretty much guaranteed the cloud's going to be cheaper if you just look at if I was starting today. And obviously you've got sunk investment, you've already bought certain things, that's not completely accurate. There might be requirements for resiliency I can't do on premises. I know companies that have a data center, but they only have one. Well, they need to do disaster recovery. Well, how do you do that with one data center? Or I know another company that had 2 data centers, but they were like across the road from each other. And so when that tornado came through, well, they both went. I might want to stand up locations on the other side of the country, in Europe, in Asia, or Australia, wherever it might be. And it's just not practical for me to stand up that sort of infrastructure. Whereas with the public cloud, I can go and spin up a couple of VMs in Europe, a couple in Asia, a couple in Australia. It makes a lot more sense for me to do that. The key point of the public cloud is it's consumption based. And this is what really differentiates it. On premises, you buy servers, you buy storage, you own it. You buy it in advance. So I'm going to go and buy big servers, I'll fill it up over the next year. I'll buy a big SAN, I'll fill it up over the next year. And I'm always paying for it, whether it's full or not. I very rarely shut down virtual machines because the server's still there. Sure, I may save a few pennies in electricity, but generally you don't bother. You leave things running all the time. That's why we don't scale on premises very much. I just stand up 10 VMs because 10 VMs is what I need at the busiest time. In the cloud, it's consumption based. Many things are like a per second. So if I consume 100 terabytes of storage, I pay for 100 terabytes of storage. I don't have to pay for 500 terabytes for most services and then use it over time. I pay for what I'm actually using. If a virtual machine runs for 12 hours a month, I pay 12 hours a month. I don't pay for the other things. This is why when we think about the cloud, we always talk about scaling. So on premises, I might have a certain box, and that box maybe has 4 CPUs and 16 gigabytes of RAM. And then I have some process running on it. Now, if that box is getting busier, it's getting more and more requests coming in, you might think about you scale up. So I'm scaling vertically. And what that means is essentially, well, I make the box bigger. I put in a bigger box. So now maybe it's 8 CPUs. Maybe it's 32 gigabytes of RAM. And so now that process, well, it grows as well. But there's limits to that. There's limits to how much resource the process can actually use often. Also, there's limits to how big I can make the box. And one of the challenges of this is, well, when I have to patch this thing, I have to shut it all down. If it has a failure, it all goes down. Also, to resize, even in the cloud, we'll have to shut it down, so there'll be a downtime. So what we prefer in the cloud is to scale out. We have smaller instances and we just add more of them. And then remember, we're paying for it while it's running. When it's a quieter time, maybe it's nighttime, maybe it's the weekend, well, we deprovision them. I stop paying for those ones. So I pay less money. So that scaling horizontally out and in, constantly changing, that's more attractive to us in the cloud. Because at a per second basis, that's when I'm paying for that thing. So this is why we really focus on that consumption basis, and why when we talk about the cloud, scaling is so important. I don't want some fixed amount of resource. I want to optimize my spend. I want to shut things down, deprovision them when I don't need it running, and start them up when I need it. That's why things like VM scale sets, containers, auto scaling in app service plans, serverless, they're so powerful because you pay for what you use. It's why when we're starting out in Azure, if we're doing a trial, shut things down at night. When you're not using it, shut it down because you're going to save money. So the fact that you only pay when something is needed, that consumption nature does make it fairly uniquely positioned for certain types of workload. So I'm going to give you an example. The Super Bowl, something I understand nothing about. My first year in America, I saw a Super Bowl and it was 5 hours long and I didn't understand what was going on. They did something for 15 seconds and then a different group came on, did something for 15 seconds. It was torture. But there's a correlation between the Super Bowl and pizza. We like pizza. So at an ordinary pizza restaurant, on a Friday night is 3 times busier than any other time of the week. Okay. So if I was a pizza restaurant, a big chain, and I had servers coming in, for 5 hours on a Friday, I need 3 times more infrastructure to support the requests than any other time of the week. So what a waste of time having to have 3 times that server infrastructure just to handle Friday night. So if we go back to our kind of picture for a second, if I'm a pizza restaurant here, so my typical amount of servers maybe is 2. I need 2 servers there, and there's going to be some kind of load balancer for the requests coming in, balancing them out. And then on a Friday night, well, I would need these. So that's for Friday, for 5 hours. So on premises, that would be really a lot of resource wasted for the rest of the week. Super Bowl is 3 times busier than a Friday night. So now all of that, well, now there's so many more boxes for 5 long hours once a year. Think of the public cloud for that. Maybe ordinarily I run these on-prem. Friday night I can burst to the cloud for 5 hours, or maybe this always runs in the cloud. Once a year, hey, I spin up a huge bunch more for that 5-hour period. And sure, I'm paying more money for that 5-hour period, but I don't mind, so I've got more orders coming in. My capacity matches demand. That's something I can do in the cloud because of that elasticity. There's like infinite amounts of resource available to me, and that consumption-based nature. So that's kind of the key point of this. I only pay for what I'm using. Think about big shopping days. Hey, if I'm an online retailer, if I'm a tax shop, there's maybe a month out the year I'm super busy. So any type of business where I don't just have kind of this consistent utilization, this is super useful. Now that consumption-based nature opens up a number of types of model. So I can think about predictable bursting. That's a good example of kind of the pizza restaurant, the tax office. I know I'm busy at certain times of the week, the month, the year, maybe at certain types of the day even. Again, we bill per second. So when I can scale in, that's real money I'm saving. Growing fast. So there's kind of a saying, I think it's fail fast, which is not very encouraging. But if you're kind of a small business, it's better to fail fast than to sort of drag and slowly wither and die. Well, when I use the cloud, I don't have to make some huge initial investment in hardware. I spin up the bare required set of services I need. If I fail, hey, I've not sunk a huge amount of money, and that's a good thing for investors. If I succeed and I'm growing, well, the capacity is there. I just start paying more money as I'm more successful. So as I grow, hey, I've got more business coming in, I'll consume more resource. So I can grow with my demand. Unpredictable bursting. So that's where for some reason my service just gets hit with a ton of traffic that I wasn't expecting. But I've got the right kind of auto scale setting set up. Maybe, hey, if a queue depth goes above this level, add more instances. If my average CPU goes above 80%, add more instances. Maybe I'm a news site. I'm a news site and some big event happens in the world. Everyone goes to my news site. Maybe I sell clothing and John Savile wears my t-shirt on a video and everyone wants to buy that t-shirt. But everyone goes to the website. So it's some type of burst activity. We can go to that on and off. This could be like a tax company. I'm a tax company. I do people's tax returns for them. I'm really busy for a couple of months. I just shut everything down. And then I turn it all back on again. If I'm broadcasting the Olympics or something, hey, there's a massive amount of infrastructure required for a couple of weeks and then nothing for a few years. So it really opens up a lot of unique capabilities that I just couldn't do on-prem. On-prem, I have to own the hardware. I can't do these things well. In the cloud, I can do it very easily. And all of these things is not just in one location. There are regions all throughout the world. So the key things I see. People start off small and will grow. There's an element of trust that has to be built up. Trust this cloud thing is real. Trust this cloud thing is secure. So trust takes a little bit of time. So companies will kind of dip their toe in the water of cloud and get that confidence built up. So test and dev is very popular in the cloud. It has a high churn. Create, delete, create, delete, create, delete. Stuff people don't want to deal with on-prem. Hey, the cloud's great use for that. I'll do my dev test testing. Now, you want to make sure the final test, the kind of unit smoke test, is done something equivalent to production. But certainly for development purposes, yeah, I could do this. Disaster recovery. If you think about disaster recovery, like a true disaster recovery, what I have is I have a location. And in that location, let's just simplify it and just say, hey, I have a bunch of virtual machines. Disaster recovery would require me, let's say there's 100 of those virtual machines. Disaster recovery would require me to have a second data center with a whole bunch of servers. Might not be 100, maybe only some of them are critical, but I have to stand all of that up for something I hope I never ever use. That's a super expensive bill when you think about the physical facility and everything else required. Or I can use the cloud, and remember it's consumption based. One of the nice things I can do, especially with things like virtual machines, but it could be any kind of app service, is as long as I'm replicating the storage, the state, if there's a disaster, then I go and create the virtual machine connected to that storage. But ordinarily, there are no virtual machines running until there's an actual disaster or I'm testing my disaster plan. So my cost ordinarily is really just the storage and kind of licensing to replicate the virtual machine. I'm not paying for compute. Now, there may be a few things I want the compute. If it's like a tier 1 SQL database, I might want to do SQL level replication. So I may have a SQL box, but it's smaller. And maybe I've got domain controller running up there. But certainly for the most part, I could replicate most of these things and not have compute charges. I'm just paying for the replication license and the storage. I have to pay for storage, obviously, but storage can be very cheap. And then in an actual disaster, then it can create all those VMs in a few minutes and I'm up and running. So disaster recovery can be hugely popular for the cloud because it's consumption based. I'm going to pay pretty little amount compared to trying to run a DR on-prem. DMZ scenarios. Maybe I'm happy with my infrastructure, but you know what? I want to start offering services out to the internet. Maybe I'm not confident about that network segregation and offering things to the internet. Maybe I need a DMZ in Europe and Asia, and I don't have data centers. Well, I can use Azure services for that. I might have a special project. Hey, I'm going to run this project for a few months, so I need to test this thing. I'm going to run that in the cloud. Many organizations today are just all in. Sure, they have a data center, but they're trying to get out of them. So they are moving as much as they can. Some are kind of moving as is. They might do some optimizations along the way. Others are actually looking at, well, can we modernize? Can we maybe re-architect, move to containers? Maybe we move to app service plans. We move to serverless. It depends on the organization, depends on the app. But a lot of companies now just, what matters to the business? Business value. And my applications that differentiate my company from someone else. That's not my hypervisor. That's not my data center. Companies care about what is value for their business. They want to generally get out the data. They want as little to manage as possible. So if I can get away from VMs to PaaS, if I can get away from PaaS to SaaS, that's all goodness for the company. And I'm an infrastructure person. But even I understand if I can do SaaS, do SaaS. If you can't do SaaS, do PaaS. VMs, there are going to be times it's the right solution, but I'm definitely looking at other things first. Now, this is old. I couldn't find a new version. This is purely there to give you some idea of the scope of Azure. We might often think about the cloud as VMs. And certainly, yes, Azure has virtual machines. Buried away down here in the bottom corner are VMs. But don't think about that as the default target for things when I'm going to the cloud. There are services around hosting app services. There's database as a service. That could be SQL. That could be open source like MySQL, Postgres, MariaDB. There are ways to run things like HD Insight. There's Databricks. There's Data Factory to help do ETL and ELT pipelines. There's machine learning capabilities. There's data lakes. There's huge amounts of storage and connectivity. There's all these amazing things. So take some time. If you have a requirement, just think about, well, what would maybe help me make this better? So take some time to understand the full scope of what is Azure. There are some good pages out there that talk about, there's like a services page that talks about all of the key services in Azure. So take a look, take some time to educate yourselves on those. And we're going to, again, cover a lot of those throughout this multi-part course. So how do I get Azure? So I can get a 1-month trial. I can get $200 of credit. I can go and sign up for that. And there are certain services that are always free. There are some that are free for like 12 months. If you have an MSDN, a Visual Studio subscription, there's a certain amount of credit. Like with my MSDN, I think it's like $150 a month. And you can stretch that a long way. If you remember to shut things down, you can do a lot of stuff with $150. If you think about things like, well, AKS, I don't pay for the management, the orchestrator part. I only pay for the worker nodes. And I can scale those things super easily. So I might have an AKS with just one worker node, and it's like a B series virtual machine costing me $30 a month out of that credit, and then scale it up when I want to do things. Then I have some virtual machines that I turn on and off. I can make that $150 go a long, long way. Or you can buy it. I mean, obviously I can create an Azure agreement. So I can create like an enterprise agreement. And then through that, I have these various constructs like departments, accounts, and then subscriptions. So subscriptions are where I create stuff. These departments or accounts are just layers of management. And to be honest, department is really going away. I would not super focus on department. Department was there if I wanted to have like a certain budgetary amount because the billing would roll up. But we now have management groups, which I'm going to cover in the governance module, that are far better than this. I still have account owners that go and create subscriptions, but for the most part, I don't super worry about this anymore. But I can create an enterprise agreement. I might use a cloud service provider, and of course there's kind of pay as you go. And again, if you are using accounts, how you structure it, again, I might have it based on country, I might have it based on business unit, I have those functional teams, I have business divisions, I have geographic. There's not a right or wrong, it's what makes sense for you. I might even use application. Often you'll have like an account owner of a business unit who can then go and create subscriptions. So I will probably have that if I'm using an enterprise agreement. If you're a smaller company, again, you might be using a cloud service provider, you might be using pay as you go. There are soft limits and hard limits in Azure. Initially, subscriptions, when you create them, have fairly low limits. It's really designed to protect you from yourself because it can be super easy to go and create a whole bunch of stuff and run up a really, really big bill and then sadness. So there are limits in place initially to kind of control what you can create, but I can raise those limits. So this page is phenomenal. It's huge, but it goes across the limit of every single thing in Azure. And it will show you the soft kind of limit, if it's a hard limit. And to raise them, I would go and actually use this subscription, usage and quotas, request increase. So in the portal, you go into your subscriptions, go to my usage and quota, and then just request increase. There's no charge for that. I'm just saying, hey, I want you to raise my quota if I'm currently at a soft limit and I've not hit that hard limit yet. I can put on spending limits. So on my account, if it's like a pay-as-you-go type thing, I can put a spending limit. hey, at this amount of money, stop. Now realize this is production and you're making things available to the public. If it just stops, that's not very good for your business. So you want to be careful of that. One of the useful things I can do is budgets. Budgets let me say, hey, set an amount and then set alerts at thresholds. So at 70% alert me, at 80% alert me, at 90% alert me a lot more vigorously, 100% start screaming. But it gives me ability to track actually what I'm spending. And again, we're going to cover all of this when we talk about called governance. So reliability in the cloud is maybe different from what you're used to on-prem. On premises, often we think about the hardware is what provides the high availability. I have a SAN, I have clusters of hosts, and I migrate VMs between hosts when I have some kind of planned maintenance. So if I think about that for a second, often, be it Hyper-V, be it ESX, whatever it is, I have host 1, I have host 2, I have some kind of shared storage. If it's not hyper-converged, if it's hyper-converged, the storage is locally, and it kind of replicates. And then kind of I have a virtual machine that's using a virtual hard disk on the SAN. So the SAN has multiple controllers, very, very resilient. If this box goes down, because these are part of some kind of cluster. So if this box is going to go down for maintenance, I would kind of live migrate or vMotion, if it's VMware, over to here. So there's no interruption to the box. If this box crashed, well, the VM would restart over here. But realize there's a downtime with that. If this just crashed, it has to come up, starts in a dirty state. If the OS crashes in here, well, then it's down. So there's limits to how much hardware level resiliency can really help me. Yes, in a planned scenario, I can live migrate or vMotion things across. If it's unplanned, it has to restart. There might be certain maintenance things required. If the OS or a component inside crashes, this doesn't help me. So there's limits to this. It looks really, really good on paper, but there's limits to what it can actually do. So, and you get this kind of false confidence. So I just have one instance of something because it's on a cluster. I'm good. In the cloud, software is used for the reliability. And what that really means is we have multiple instances of things. That's the model. Because typically VMs are not migrated during maintenance. So if we go back to this model for a second, if I think about Azure, there were still racks and racks of servers and there's all these blades in them. So let's just say I have multiple racks. The way we do things in Azure is your service, you'll actually have at least 2 VMs, ideally to get the full SLA. They will be part, doing some sort of cluster, there'll be a load balancer to balance traffic. If this node has maintenance, this will temporarily, now most of the time today, Azure has these things down to these preserving host updates. It maybe is unavailable for seconds, it's talking about. They don't patch the host, they just reboot them to a host image that has the patches. They can even inject patches into a running kernel. It's crazy stuff. But they don't live migrate things around. None of the clouds do. It's just not something they do. So I have multiple instances. So if there's planned maintenance, it's unavailable for a few seconds. If a host crashes or a rack crashes, I'm still running. I have another instance over here. If the OS or app crashes in one of these, well, that load balancer that we have up here that's taking kind of that incoming request and then balancing it, well, it does health probing. So if the app stops responding in a healthy status, it will stop sending things there and just send it to the healthy ones. So what we think about in the cloud, and this might be a shift for our app, rather than having one big instance of the app with 16 CPUs and 32 gig of RAM, we'd have 2 or more smaller instances. So the cost is the same. 2 VMs of half the size cost the same as 1 big VM. But we have much better resiliency. I can scale things out. Now, if the app doesn't support multiple instances, that's where we can hit a pain point. We might have to do some app re-architecture to support those multiple instances. But it's definitely something, when I think about moving to the cloud, if I can, I really want to try and focus on being able to have multiple instances of the application, because that's how we really get the good resiliency. One big thing that moves around is limited. If it crashes inside, if the host crashes, it's not really the best resiliency. So this software level resiliency is actually a better option. Now, the data centers Azure uses are super resilient. They have phenomenal protection from power failures, cooling, redundant communications. I mean, there's amazing stuff there. And if they detect failures are coming, there are times it will live migrate things. If it detects a hardware failure is imminent, it will potentially move some things around. But the real protection is multi-instance. When you think cloud, think 2 or more instances of my service. They're smaller, it's costing me the same, but it may require my app to have a bit of re-architecture. So reliability in the software is the only practical option for mega scale, which is what the clouds are. But it's actually better. But I do have to factor that in as part of my architecture. Again, that resiliency is going to hit far more types of failure, be it in the guest, at the rack level, than just some live migration or planned scenario. Now, just super quick, there's obviously many clouds out there. Why should you use Azure? So Gartner is one thing some people look at, how seriously you take it, how important that is to you, it varies. But they have this kind of magic quadrant thing. And generally you want to be over here in leaders. Leaders kind of means, hey, I've got a completeness of vision and I've got an ability to execute. And so Microsoft is in the leader for many, many of these. But obviously what I'm focusing on right now is cloud infrastructure and platform services. So it's one of, I think there's 3 leaders in there right now. It's also, they've actually retired the quadrant for things like server virtualization. So it could do a leader in on-prem with Hyper-V and in the cloud. And there's tons of others like enterprise mobility. I mean, there's tons and tons of these things. It's a leader, but it's considered kind of a good horse to bet on. So Azure and Hyper-V are leaders. I can therefore get a hybrid solution. Now, this is not that big a deal these days, but it used to be. What about this feature? Does Azure have this? And this is kind of, this is a Gartner. This is the Gartner hype cycle. Now you can actually say this applies to anything in life. Anything in life. You find out about something. So there's some trigger. You get this peak of inflated expectations. This is going to solve every problem I have. And then when you actually get to use it, you're like, oh, it doesn't. You get this trough of disillusionment. And then, okay, you keep at it. You get this slope of enlightenment. And then you get actually productive using this thing. And this really does apply to everything. My kids could kind of could map to this as well. But the point of it is, when you first find out about something, you only focus on the features. That's all you can think about. What does it do? What does it do? Does it do this? When you're actually really using it, you care more about how the things work together, how they're going to work with my other components. Now, again, Azure today is one of the leaders in this field. They are constantly adding new capabilities. Chance if it doesn't have a feature, it's on in the way. But just bear this in mind. If you're new to the cloud, it can be super tempting to just look at a piece of paper and say, well, what features? You need to understand the complete picture and think, okay, well, how is this going to work? How is this going to migrate? How am I going to use these things together? That gets more important for most of us. So what does this all mean? Azure's one of the few realistic big guys in the space. It costs billions of dollars. I mean, I can't remember what the right number is, but it's billions and billions every year Microsoft is spending on Azure, standing up new regions. It costs a huge amount of money to do this. Very few companies, obviously the other big one is AWS. Google Cloud is also, they're a bit less popular, but they're making efforts. There are others that are trying to get into the space. I think most of the others, though, will be niche players. Outside AWS, kind of Google, Azure, everyone else will probably carve out maybe a specialized space they will use. That's my opinion. Obviously, I'm biased anyway. I mean, I work for Microsoft, but I think that the big three are kind of the AWS, Azure, Google. So you're betting on a good horse, and obviously there's doing a lot of things around machine learning and self-awareness. So if Azure does become self-aware, as an early adopter, it'll probably treat you the best. So this was the introduction, kind of the fundamentals module. In the rest of the modules, it'd be a lot more kind of hands-on. I'll be showing things, demoing the technologies. This was kind of set the groundwork. But any questions, please ask in the comments. Thank you.